Hello, 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 welcome everyone. Today I'm here to give a presentation on winglet wonders, exploring aerodynamics through CFD simulation. Mm. Before getting into topic, I will give a small introduction on myself. My name is J. Simon Reddy, having a PIN number of 21955A2109. I am from Department Aeronautics. Mm. I am today here to give a presentation on winglet wonders by exploring aerodynamics by exploring by exploring aerodynamics through CFD simulation. So let's get into topic. Before getting into topic, I would like to express the timeline of this presentation. In this presentation, we are going to deal into sorry. In this presentation, I divided the whole presentation into few sections. The sections consist of introduction, methodology, results, limitation, conclusion, and reference. So let's get into it. Introduction. Aircraft winglets has become a common feature in modern aircraft design. These winglets are installed at the tip of the wings and helps to reduce drag, increase efficiency, and improve stability during flight. In this study, we will analyze the performance of aircraft winglets at different angles using computational fluid dynamics simulation. The result of this analysis will provide valuable insights into the impact of winglets angle of aircraft performance. In this figure, we can able to observe the the tip of the section which consists of a winglets. In modern aviation, the winglets has become important, or it's became most important in terms of in order to achieve the higher efficiency, because winglets can able to reduce the vertices and can able to improve the efficiency up to 5 to 6% above. Minimum we can able to achieve 5% of efficiency in increase. Annex methodology. To conduct our analysis, we use CFD software to simulate the flow of air over a wing with a winglet attached. Mm. So, so, so I carried out the experiment in which I consider a wing with an winglets, and I basically subjected the wing, and I basically subjected the flow over the airfoil in which it consists of the winglet. And next, I varied the angle of winglet from 0 to 45 degrees in incremental of 5 degrees. So therefore I carried the experiment to for about of 9 times, in which initially I carried the experiment at 0 degrees, and next I increased a constant 5 degree incremental. For case 2, I suppose the winglet at 5 degree of angle at 5 degree, and next 10 degree, like so on, 15, 20, 25, 30, 35 up to 45 degrees. And and while I carrying this experiment, I recorded the results and drag generated by winglets at each angle. Next, I also analyzed the vertices created by winglets at different angles. Why? Because the vertices plays a crucial role in reducing drag and increasing the efficiency. As you know that in day-to-day application, the aircraft which can able to generate, or which supposed to have uh, most efficient ones when compared to other, the aircraft is well receives a most orders due to the efficiency. Annex Annex result. After I carried this experiment for throughout, so in this we can able to understand. I carried the experiment throughout it, and next I get the results. Annex results. I analyzes I analyzed and revealed that the optimal angle for an aircraft winglet depends on the specific design, or operating conditions of the aircraft. So therefore, I don't suggest the winglet should be supposed to be at a typically 5 degree of angle attack, or something unique of angle attack, or something your unique angle of attack, because the angle of attack of winglets is depends upon the surface or the design of the aircraft. So so if we change the design of an aircraft, as a result we should supposed to change the angle of attack of a winglet, because design is directly proportional to the winglet. So if the design is similar of all aircraft, then we no need to change the winglet angle. Suppose the design is vary, then we need to change the value of winglets, because winglets angle of attack is defined or depend on the this parameter. Next, in general, however, I found that winglets angle between 25 and 35 degrees provide the greatest reduction in drag and improvement in efficiency. So for an ideal condition, irrespective of design, the angle of winglets range in between 25 to 35 is an ideal condition in order to achieve maximum efficiency. So so mm, so irrespective of design, whether the design is changed, or the previous design or new design, but the ideal case is, if we supposed to make a angle in between 25 to 35, it becomes positive for us. Next, and they also observed that as the angle of winglet increased, the size and strength of the vertices generated by the winglet increased as well. And when I carried the experiment from an 5 interval for 5 degree of incremental, I understand that as a result, when I supposed to increase the angle of winglets, as a result, the size and the strength of vertices are supposed to also increase it. So we can understand that if the aircraft have high angle of winglets, it will supposed to counter high winglet strength. I suppose it is respect to counter the vertices which is high when treated to the other conditions. And I suggest that there is a limit to the angle at which winglets can be effective, beyond which the increased drag from the vertices outweighs the benefits of reduction overall. So I understand that mm, I will there will be an exact limit at which we can able to predict the drag in any curve format with respect to other parameter. But whenever we supposed to extend or go beyond the limit, then as a result the drag suddenly tends to increase. So we need to estimate the limit, and we not and we should able to come and understand that the design of the winglets, the angle between them, it should not be greater than the limit, in order to in order to in order to get the lesson. The next, limitation. It is important to note that I was analysis conducted using a simplified wing model and did not take into account factors such as turbulence, altitude, and speed variation. Additionally, the results of my study may not apply to all aircraft design and operating conditions. Further research is needed to fully understand the impact of winglets angle on aircraft performance, and to develop optimized winglet design for different types of aircraft. Conclusion. So my conclusion is, I no conclusion is, mm, I had carried out the experiment with with many many assumptions. So for example, I does not consider the turbulence. And next, I does not consider the side angle, the side force. I simply consider that the which are parameters I'm going to apply to this, I simply 1 2 parameters I just applied, and remaining parameters I supposed to take it at 0. It consider as 0 or consider it as negligible. So therefore it's not effective for the day-to-day life application. Reference. I refer the following concepts from the reference of the two books. And thank you.